Okay, welcome to this video on the cosine rule. Before you watch this video, you should have watched the area of a triangle, any triangle, in National 5, and the sine rule video. This is the third video, and it consists of the cosine. Again, the cosine is similar to the sine rule in the sense that we can work out an angle or a length based on the information we've got. Now, sometimes when you're using the sine rule, you don't have enough information and you can't work out a particular length or a particular angle. The cosine rule cares for that. So when you can't use the sine rule, then we need to use the cosine rule, and we'll talk about the difference between them in the next video when I do mixed questions and some past paper questions. That'll be my next video. So we're just going to concentrate on the cosine rule just now. And I'm going to show you where it comes from, just like what I did with the sine rule. So, first thing we always do, if you've been watching the videos, is label the diagrams. So this is small a, the length small a, small b, and small c. This is angle A, angle B, and angle C. Now, what we're going to do is just the same as the sine rule. We're now going to put a vertical line down, such that it makes a right angle here and here. So we've got the two triangles again. So this whole length is B. I'm going to call this bit X. So this side here must be B minus X. Hopefully that you understand that. This whole length is B. Okay, so if I call that X, then this bit must be the B minus the X. Okay, now again we've got the H for the height, and this time instead of using SOHCAHTOA like we used for the sine rule, this time we're going to use Pythagoras on this triangle. It's a right angle triangle, so the height squared must be equal to c squared minus x squared. Okay, that's just from Pythagoras' theorem. And for this triangle, same idea, then h squared must be equal to a squared, that's the hypotenuse, minus b minus x squared. So what we're saying really is that must be equal to that. Okay. Other thing that we want to consider, because when we rearrange these and cancel out and things, we have to know what x is. So using our SOHCAHTOA again, then cos A is equal to x over c. Therefore, x must be equal to c cos A. Okay, we're going to use that in a wee minute to come up with this formula. So let's make these two equal to each other. So I'm going to write a squared, I'll write this one first, and I'm going to multiply this bracket out at the same time. Okay, so multiply that bracket out at the same time, I get b squared minus 2bx plus x squared. Okay, that's me multiplying that bit out. And that all must be equal to c squared minus x squared. Okay, so let's multiply through by the negative here to get rid of the bracket. So we're going to have a squared minus b squared plus 2bx minus x squared is equal to c squared minus x squared. Okay, so we've got a minus x squared and minus x squared, so they can cancel out. So I'm left with a squared then. And I'm going to take everything else over to the right hand side, so I'm going to add on a b squared to both sides, so that's b squared. I've already got a c squared, and that's going to the other side, so that's going to be minus 2bx. We're nearly there, so a squared That's the length, this length up here squared is equal to this thing here. But we don't want the x in it. So the x that we have here is equal to that up there that I've just defined. So we shove in BC cos A. Okay, and that's the formula that you're given at National 5 based on that diagram. Now there are variations on this, just like when you've done the area formula. You can write b squared is equal to a squared plus c squared minus 2ac, and this time it cos b. And the other version is c squared is equal to b squared plus a squared minus 2ab cos c. Probably better to swap these round actually, in numerical order. Probably the best idea. Okay, but you're not given these two in the exam. You've got to work with this one essentially and rearrange it if you need to. Now, my advice to you here is that when you're doing your diagrams, you need to label it and label it carefully. Okay, so I'll just mention it here, but I will mention it in the next video as well. Cosine, when do we use the cosine? Use the cosine, so use cosine when we know all lengths in a triangle, or SAS. Now remember what I said the SAS was in the area video? SAS. If you've got two sides of the angle in between, that's when you use cosine. Okay. Every other time you use the sine rule, but we'll come back to that when we do mixed questions. So we've got that there, and we're going to try some very simple questions. Now I'll start off with finding a length. That's usually the first way we start. So we'll need to draw a triangle, and again I'll just roughly do it. Okay, I've got a triangle something like that, and I'll put a value of 5 meters on this one. So that's the length of that one, and we've got 12 here, and we've got an angle of 43 degrees, which is in here. And question is, what's this side? I'll put a wee question mark here. What's the length of that side? That's what we want. Well, first thing we have to do, label it. Now based on what we've got here, I'm going to label that A, B and C. Now, if you try and do the sine rule for this, it just won't work. You don't have enough information. So the only thing we can use here is the cosine rule. And let's label a diagram fully. So we're actually trying to find A here. So the question mark is actually A, and that's what we're trying to find. B is down here, and my C is up here. Okay, so using my formula I just derived, this other side there, I'm going to have A squared is equal to B squared plus C squared minus 2BC cos A. Okay, so just plug in the numbers. So A squared is equal to, that's going to be 12 squared plus 5 squared minus 2b is 12 times 5 and cos of 43 degrees. And we bump that into our calculator. So we'll bump that into our calculator. Just give me a wee minute to do that. And we'll get an answer of, nearly there, 81.28. Now that's meters. Now remember, that's A squared. So to get A, we take the square root of both sides. So we'll take the square root, both sides, square root of that. Well, it's approximately 9, isn't it? Let's see what we get with the calculator. 9.02 metres. And that's the length of BC there, the question mark that we'll try to find. Okay, that's quite simple once you know the formula, and just plug in the numbers. Again, with about 3 marks that one, I would imagine, in the exam. Now, I'm going to show you something back over here, back over this side. We can rearrange this formula, and the good news for you is you do get it in the exam. I'm going to put a wee arrow here because these two things are the same. I can rearrange that formula into cos A equals, well, that's going to be B squared plus C squared minus A squared all over 2BC. So that's the other version when you're trying to find the angle. Useful to know. Again, you get it in the exam, so you don't have to memorise it. But with all these things, you should be doing enough practice. And if you're doing enough practice, then you'll know them off by heart. But if you don't, at least you know you get them in the exam anyway. Okay. So let's look at a question to do with the angle then. So again, I have to draw something out. So let's draw a rough triangle. Okay, again, A, B, C, and let's put 11 in here, 11 centimetres, and I've got 9 centimetres here, and I know another length as well, and that's 16 centimetres. Now let's label it. So A, B, C. Okay, so that's really, really important. Okay, and question says, can we find this angle here? Angle A. So angle A, if you look over just to the other side, here's my formula that I rearranged. Now, if you find that really hard to memorise and whatever, if you just remember this one, plug in your numbers, and then you have to rearrange that into cos A. You can do it that way as well. But I prefer to memorise that. So, write down my formula. B squared plus C squared minus A squared all over 2BC. Notice how we know all the lengths there. That's one of the criteria to know that it must be the cosine rule. Okay, so let's stick in our numbers then and see what comes out. So here we go, we've got B, which is 16, so that's 16 squared plus 9 squared minus 11 squared all over 2 times 16 times 9, and bump that into your calculator, and this is what you get. I'm putting it in my calculator just now, and get 0.75. 0.75. So A then, the angle A, degrees must be shift cos 0.75, and A then is equal to, well, again bump it in the calculator, and we get an answer of 41.4 degrees. And that's how you can find an angle using cosine. Now, the last one I'm going to do with you is going to be a past paper question. Now, there's lots of past papers on this. As I say, it comes up every single year without fail. and you always get the two of them. You always get the sine rule, you always get the cosine rule, you also get the area, always get the area of any triangle using, remember the other video, A equals a half AB sine C, that one, that always comes up as well. So you'll find loads and loads of practice on this. Okay, so I'm just trying to find past paper question for you. Hopefully we can get there. Let's bear with me. Yeah, I've just got the past papers in front of me here. So here's something we can get to then. In a wee bit of time, but we'll get there. Okay, I'm just finding the past papers now. Good. Right, there was one particular one that I thought was quite good. So here we go. Yeah, want to do the length of the road. Okay, so I'm going to wipe this away and let's look at past paper. It's worth about, I think this one's worth about 4 marks or so. So we have a triangle. Again, I'm not writing down all the words for you. Here's a triangle, and we're told that this angle in here is 76 degrees, and we're given two lengths. We're told that this length in the left here is 80 centimetres, and the bottom, the base of it, is 40 centimetres. Now, this question is all to do with a trapdoor, some trapdoor that they've got, and they want to find the length of this road here. Okay, so that's all you're given in the exam. So we have to find essentially whatever this side is. Now, be sensible with it. It didn't give you any labels, so we'll make it A, B and C again. Always easiest. Label the sides A, B and C. And as I said to you, we have to find this length A. Just mentioned it as before, if you try to do the sine rule on that, it won't work. This is SAS. SAS, the wee note I gave you on the left hand side here, SAS tells you it's the cosine rule. Really, really important that you get familiar with that, and it makes these questions so much easier. So we don't have to decide what we're using, we know it's a cosine rule. So let's write it out. A squared is equal to B squared plus C squared minus 2BC cos A. So it's nice and easy now, we'll just bump in our numbers. So we've got 40 squared plus 80 squared minus 2 times 40 times 80 and times cos of 76. Right, it's going to take me a wee bit of time to bump that into my calculator, but here we go. Here's the calculator, so we've got 40 squared plus 80 squared minus 2 times 40 times 80 times cos of 76. Close the bracket, and comes to an answer in my calculator to 6451.699 approximately, obviously. So take the square root of both sides, so A is equal to the square root of this, 6451.699, and working that through, 80.32, and that's centimetres. So the length of that road that was in the question is 80.32 centimetres. Very close to the size of that one. Okay, and that's us done the cosine rule. Now, I haven't done very many past paper questions in these. The wee examples I was giving you were straightforward ones. with a past paper at the end of the video, just one. I'll do another video that's going to be a mixed past paper questions, so I'll maybe do 5 or 6 past paper questions on the next video, and it'll be called mixed sine and cosine rule, and that's the one that you really have to know. Now it tends to be, if you get the dead easy ones, then it's just a straightforward sine and cosine, but the vast majority are sine rule with a bit of SOHCAHTOA, or cos rule and area, because they go nicely together. And they also do bearings. Questions can involve bearings, so you should have done bearings further down the school. Bearings, remember, 3 figures, north all the way back round, so 0 degrees all the way round to essentially back to 0 or 360. That's the bearing type questions, and they tend to be cause the most problems if they come up. I haven't saw them recently. There's mostly been very straightforward recently, but we'll do a few of them as well. Okay, that's the end of this video.